Oops. So I talked about this, just diving into a little bit more detail about the environment. Again, completely graphical. We saw the context-sensitive help. We saw how all these blocks, these functions, well, you can create your own. You can modularize code using self-ions. And you can implement common programming structures, like command variables and state machines. And in a moment, when I get through this, I'll give you a demonstration of our team's code, which implements both of these things. As I mentioned, parallelism. I think I talked about this. Basically, the idea that nothing runs until data is at all its inputs. So, if there's no input between the two, they run in parallel. One of the things I hope I have time to show you is, in our robot, we implemented speed control using a PID loop. And we actually had parallel control loops, one for each wheel. And it used the same code, literally the same VI. It had a function called reentrancy, which means you could run the same code multiple times, and it would run in a different memory space. So we had to just debug one wheel, and then deploy it 4 times. So that was kind of a neat, more advanced topic. Okay. Another nice thing, I talked about both of these points, except for one which I missed, which is in LabVIEW. You can test the logic of your code, your program, without being connected to the compact wheel. I did a tip jar video which explained how to do simulation on your laptop, on your development lab. And it's a matter of replacing all your hardware calls with inputs and outputs, simulated inputs and outputs on your computer program. What that allows you to do is, if you have, say, a complicated program flow, where you go from an idle state where you're waiting for a ball to be present, if you detect a ball, then you take some action. You can totally prototype that using just your computer. And that's nice when you don't have a robot ready, which for many of us was probably up until 3 or 4 days before ship. I don't know, show of hands, I know it was certainly our case. Okay? And that's also really nice when you've got some very keen, very smart programmers who want to do work on the weekend or in the evening, and they've got their laptops and they've got their install of LabVIEW and they've got their copy of the code. Well, they can do some testing. They can do testing and simulation. One point I didn't mention about LabVIEW, in Vision in LabVIEW, is that you can use the Vision Assistant. In the previous presentation, Greg Pascal from National Instruments talked about and gave some demonstrations of this, how to use the Vision Assistant in LabVIEW. And it's a great kind of drag and drop wizard-based way to prototype your vision. And what's really nice about it is you can push a button, creates a VI, which you then drag into your project and use it. So prototyping tools for vision are really there. So, in summary, how do we get there? How do we get to the point where we can make a decision based on all the information? Well, number one is avoid technology religion. As I mentioned, as I really emphasize, is a great opportunity to teach students to evaluate. Evaluation is such a hard-to-learn skill. Again, there's no harm in learning multiple tools. Learn them both. Divide and conquer. But I still feel, and I've often said this, that what's important about programming really has very little to do with the tools you use or how you use them. If you can take the task, which is to create a robot which is going to beat all the other robots in the field, and you can write an excellent flowchart which explains how to do it, or you can write pseudocode, and you can draw diagrams, then the task of taking that code is far, and taking that code and actually implementing it on the computer and then on the C-reel is actually less important than coming up with the good algorithms in the first place. So I think that I've always said that the programmer's best tool is a pencil and a brain. Okay? And with that in mind, I think the students should be careful to think, well, what makes it easiest for me to take this idea I have and implement it on the C-reel? The path of least resistance, the path which gets them closest to taking that idea and making it go, is the right path for them.